Bismillahirrahmanirrahim. Dear students of 9C, Assalamu alaikum. I am your teacher, Muhammad Ilyas, and this is our ninth interaction regarding chemistry for Cambridge. Dear students, our today's topic is formula, stoichiometry, and the mole concept. And according to CI syllabus, this is your topic number 3. And according to your practical book, this is experiment number 6, a practical book chemistry, a course for O level volume 1 and the page number 22. Dear students, our objectives are as follows. We will be able to understand the practical procedure and solve the questions given in the practical book or in your practical journal. We are going to carry out a quantitative investigation of moles ratio in a chemical reaction, and secondly we will focus on how to calculate stoichiometric reacting masses with the help of Avogadro's law. So these are our two objectives for today's session. So we are moving towards our next slide, and this is to show you, to revise you to stoichiometry, and this is the relationship between the relative quantities of substances in a reaction or forming a compound. So dear students, stoichiometry is a relationship between the relative quantities of substances which are going to react as reactant in a reaction are going to form products. Now we are moving towards the mole concept. 1 mole of a substance has a mass equal to its relative atomic mass, relative molecular mass, or relative formular mass expressed in grams. Here is an example of sodium. You can see the atomic mass of sodium is 23 and the average atomic mass is 22.99, and if we are going to take its relative atomic mass 23 as a standard and we expressed in grams, then this will be the molar mass of the sodium. It means that if we take the 23 grams of sodium, it is 1 mole of sodium. And here are a few examples of the compounds which will help us to calculate the molar mass of the compounds. The example is calcium chloride, and you can see from this slide that the calcium chloride is having two types of atoms, calcium and chlorine, and the chlorine are 2 in numbers. Chlorine atoms are 2 in numbers. So we are going to calculate the molar mass of this compound calcium chloride. First of all, we are going to take the atomic mass of the calcium, that is 40.08, and secondly we are going to take the atomic mass of the chlorine, that is 35.45, and if we combine these two masses according to the calcium chloride formula, then we can get 110.98 of this calcium chloride. How? 40.08 for calcium, and because chlorine is having 2 atoms in this compound, so 35.45 multiplied by 2, and then we add this, and this will be 110.98, and if we express this 110.98 into grams, then this will be the 1 mole of calcium chloride. In this how we can get the molar mass of the compounds, the different compounds which you are going to calculate the molar mass. This is the simplest way to calculate the molar mass of the compounds. Dear students, how to calculate the moles? This is the very simplest formula to get the number of moles from the mass. If the mass of the compound is given and we have to get the number of moles, then what should we do? We just simply divide this mass with the molar mass. The given mass divided by the molar mass, we will be able to get the number of moles. And dear students, if the number of moles are given and we have to calculate the mass of the substance, then we simply multiply the number of moles with the molar mass, and we will be able to get the mass of that substance. Here is a very illustrative way to get the moles. If the particles are given, mass in grams is given, and the volume of the gas is given, we can simply calculate the number of moles. And from the number of moles, we can calculate the number of particles, the mass, and the volume of the gas. Very simple. First of all, as I have mentioned earlier, if the mass is given, we have to divide that mass with the molar mass or the atomic mass, and then we will be able to get the number of moles. And if the number of moles are given, we will simply multiply it with the molecular mass or atomic mass, and then we will be able to get the mass in grams. And dear students, if the number of particles are given, then we have to divide the number of particles with the Avogadro's number, and that is 6.02 into 10 raised to power 23. In this way, we will be able to get the number of moles from the number of particles. And if the number of moles are given and we have to calculate the number of particles, then we just simply multiply the number of moles with the Avogadro's number, and that is 6.02 into 10 raised to power 23. In this way, we will be able to get the number of particles. Dear students, now we are moving towards how to convert the moles into volume of gas, and if the volume of the gas is given, then how we can calculate the number of moles. Dear students, if the volume of gas is given, we have to divide it by 24 cubic decimeter, and in this way will we be able to get the number of moles. And if the number of moles of a gas is given, then we have to multiply that number of moles with the 24 cubic decimeter, and this is in this how we will be able to get the volume of the gas. This is the way in which we can simply get the number of particles, volume of the gas, and the mass from the number of moles, and we can convert the number of particles, volume of the gas, and the mass into moles. Dear students, another way to simply express this, the conversion from particles, mass, and volume into moles, and from moles into particles, mass, and volume. Simply, if we have the particles number divided by the Avogadro's number, that is 6.02 into 10 raised to power 23, then we will be able to get the number of moles. And if the number of moles are given, we have to multiply that number of moles with the Avogadro's number, and we will be able to get the particles. Likewise, the mass. If we divide the mass with the molar mass, we will be able to get the moles, and if the moles are given, we have to multiply that moles with the molar mass, we will be able to get the mass. And same is with the volume of the gas. If volume of the gas is given, we have to divide with the 24 cubic decimeter, we will be able to get the number of moles. And if the number of moles of a gas is given, then we have to multiply it with 24 cubic decimeter, and we will be able to get the volume of the gas. So this is the thorough explanation to you how we can convert the moles into particles, mass, and volume, mass, and particles into the moles. Please memorize this, and this will help you a lot. Now, dear students, we are focusing on the equations. What is equation? A chemical equation describes what happens during a chemical reaction. The general form of a chemical reaction is the reactants, which are going to convert into products. For example, iron is going to combine with sulfur and form the iron sulfide. The ionic equation represents the reaction between the ionic compounds in aqueous solution. This is the illustration. A molecular equation shows you how the reactants are going to form the products. As you can see from this equation, lead nitrate is going to react with the potassium chloride and form the lead chloride and potassium nitrate. This is the complete ionic equation to shows you what happened during the chemical reaction. So after having this understanding of equation, which is a chemical equation, describe what happening during a chemical reaction, Now we are moving towards our experiment. This is experiment number 6 according to your book, a practical book for chemistry, a course for O-level, volume 1. We have to carry out a quantitative investigation of moles ratio in a chemical reaction. And for this purpose, dear students, we need apparatus, a crucible, pipe clay triangle, Bunsen burner, matchboxes, and digital balance. And beside this, we have need a strand, a retort strand. The material which is required, it is anhydrous hydrogen carbonate. Dear students, I have selected this picture for you so that you can have the better understanding of anhydrous sodium hydrogen carbonate. This is the white powdery form of sodium hydrogen carbonate. You can see for your better understanding about this compound. Now we are moving towards the apparatus setting or arrangement. This is the diagrammatic arrangement, the Bunsen burner, retort stand, ring clump, clay triangle to hold the crucible with the lid. And this is the laboratory arrangement. You can see the Bunsen burner, ring clump and the crucible. And we are heating. You can see in this picture that the flame is blue. The blue flame giving maximum maximum heat. So after setting this arrangement of the apparatus, what should we have to do? We have to go for the procedure. Dear students, we have to weigh a clean dry crucible and record its mass. Secondly, we have to add approximate quantity of anhydrous sodium hydrogen carbonate, anhydrous sodium hydrogen carbonate to your crucible. Weigh again and record the combined mass. This will help you to calculate the weight of the anhydrous sodium hydrogen carbonate. Thirdly, we have the crucible at first gently for 2 minutes and then for 8 minutes. Fourth, allow your crucible to cool. When it is cool, weigh it and record the combined mass of your product plus crucible. Product will be sodium carbonate. And the fifth step for this procedure, we have to observe the product and describe any changes in its appearance. Results. Dear students, when we heat the sodium hydrogen carbonate, it produces 3 products: sodium carbonate, carbon dioxide and water. Carbon dioxide, as you know, is a gas will escape into the air, while the water will convert on this heat into vapors and move escaped into the air. What left? Sodium carbonate is left. You can see from this equation, the sodium hydrogen carbonate is going to convert into sodium carbonate plus carbon dioxide and water. And this is the picture of sodium carbonate, you can see. And now you can analyze the difference between the sodium hydrogen carbonate and sodium carbonate. I have selected these 2 pictures for you so that you can easily understand the difference between sodium hydrogen carbonate and sodium carbonate. This is white solid in powder form. So dear students, after having this understanding, now we are moving towards the calculations. And you have to calculate all the questions which are given in your journal. For example, you have to find out the mass of the sodium hydrogen carbonate and the mass of the sodium carbonate. which is produced as a result of this reaction. Then you have to calculate or determine the number of moles of sodium hydrogen carbonate and the moles of the sodium carbonate. And for this purpose I have helped you so that you can calculate the other questions. The quantity of anhydrous sodium hydrogen carbonate which is taken is 3.54 grams, while the quantity of sodium carbonate is 1.30 gram produced after the reaction. So this is done for you. Now you have to calculate the other questions and answer them. And this is your homework, experiment number 6, and you have solved all the questions given on your practical journal, page number 23 to 24. Dear students, you solve these questions and then send into your groups so that it can be these questions can be evaluated by your teachers. I have selected a spelling test for you. These are the few words you have to memorize the spellings of these words. First is investigation, anhydrous, carbonates, decomposition, approximately, appearance, crucible, determine, quantitative, Bunsen burner. Dear students, you have to memorize all these 10 words with spellings, and then you have to write into your notebooks and send into your respective groups for checking. This is a question which I have selected from the past papers for you as a test. Write on your in your test notebooks and send into your respective groups for checking or evaluation. So this is the test for you. Thank you very much, dear students, for being with me. And one more request to you, please stay at home, stay safe. Allah Hafiz.